Hello everyone. So today we continue with our discussions on instruction format. So we have already seen that in an instruction we have three fields. The first is your operation code, which tells you which operation is to be performed. The second comes the addressing mode, which tells you how the addresses that are given in the next field are to be interpreted, whether these are register addresses or whether these are memory addresses. And finally, we have the third field is the address field. So the address field gives us the address, either register address or memory address, where the operands on which this operation is to be performed, where they reside. So these are the three important fields in the instruction. Now we had also discussed that the number of addresses that is given in an instruction may be different. So we may have different number of address fields. So as a result, what happens is that the instructions can be of different lengths. So as you can see in this example, so you have two register addresses, here you have three register addresses, here you have one register and two memory addresses, and the last one we have only one register address. So each of these instruction they have different length because the number of addresses are different. Also the type of addresses are also different. Like some are register addresses which will require lesser number of bits, and the others are memory addresses, so they will require more number of bits. So how do we decide which of these representations is to be used? So this depends on the internal organization of the registers. So the way in which the registers are organized in your particular computer, that will tell us whether we will be using 2 address or 3 address or 1 address and so on. So in this class we will look at the different register organizations that you can have. So the first type of register organization that you can have is a single accumulator organization. Single accumulator organization is where you have only one register. So you don't have any other register, you have only one CPU register, and that register is known as the accumulator. ACCUMULATOR. The accumulator register. So there is only one register, and in this, if you have only one register, your instructions, this machine with this having this type of register organization will have only one address field. So I can have, for example, you can see in this example here, add X. So let me just write it in a different page. So I have only one accumulator register. Let us call this AC. AC is the accumulator register. So I want to perform an operation. So I suppose I want to write A is equal to B plus C. So I want to perform this operation. So here I have only one register. So what I have to do first, I have to load B into the accumulator. So we will write it like this in a pseudo assembly language. Load B. So this will take the memory location B, the contents of memory location B, and put it in the accumulator register. Next, what we will do, we have only one register, so I have to add, when I add with B, with the contents of the accumulator, I have to mention, I have to take the other operand directly from the memory. So I will write add C. Okay, so what will happen now? The contents of the accumulator register that we have here, this will be added with the memory location, contents of memory location C, and then we will get in the accumulator register, we will be storing B plus C. So this, what it does, it takes the contents of memory location B and puts it in the accumulator. in the accumulator register. And this instruction, what it does is that it takes the contents of the accumulator register and adds it with the whatever we are giving here. So this is memory location, so MC. And the result of this sum is stored back into the accumulator register. So load A, add C. Now this operation is not over yet. We have to store the contents of the accumulator, which contains B plus C, into A. So we will write like this: store A. So what happens now? For this, we will have the contents of the accumulator will be stored in memory location A. So as you can see here, we have for performing this particular operation, A is assigned B plus C. These are the instructions that we have to write, and all of these, you can see, contains only one address. So these are the operations, and these are your operands. So this is a single register accumulator register organization. The second type is our general register organization. So this is a normal, which is very common, most common. That is, you have more than one general purpose registers, and your instructions formats may have either 2 address or 3 address fields. So like as you can see here, add R1, R2. So takes the contents of R1 and R2, stores it in R1 again. Similarly, if it is a 3 register, 3 addresses, then takes the contents. The first one will indicate the output register, and the next 2 will be the input registers. So R1 is assigned R2 plus R3. In the first case, the sum of R1 and R2 is stored back in the first register, which is R1. So this is your general CPU register organization. The third type is something known as a stack organization. So in a stack organization, you have 2 main operations: push and pop. So the push operation, as you know, is used for storing something at the top of the stack, and pop is used for removing the element at the top of the stack. So for push and pop operations, it will take one address. Like you can see, push X. Push X. This means take the contents of memory location X, push it to the top of the stack. And pop does not take any value. So similarly, it just pops out the contents of the at the top of the stack. And the other operations, that is, say, add, subtract, multiply. So add, subtract, multiply, they do not take any arguments, or rather I should say, instead of arguments, I should say they do not take any addresses. So add, what does it mean? Where are the operands going to come from? The operands would be the 2 elements at the top of the stack, because remember, from a stack you cannot take anything else out. Only removal is allowed from the top. So add will come with 0 addresses, no address. So if it is a stack organization, then you have 0 address. So if you look back, if we have a general CPU register organization, we may have 2 address, or we may have 3 address. If we have single accumulator organization, then I will have only 1 address. And if you have stack organization, then you may have 0 addresses for the main operations. For push, you will have one argument, but not for the others. So depending upon the CPU organization that your computer uses, you will have different sizes of, or the lengths of, your instructions. So let's see one typical example here. So we have an Intel 8080 microprocessor. So here, what is the organization in this for this particular computer? So this computer has 7 microprocessor registers. So it falls under your general register organization. But one point to be noted here is that you have one of the 7 register is an accumulator. So it's a combination. So you have a general register organization plus you have a single accumulator organization also. So out of 7 registers, 6 are general purpose, 1 is the accumulator. So it combines the elements of accumulator organization as well as general register organization. So what about the address instructions? So you can see here all arithmetic, logic and load store instructions are single address. Okay, that is your accumulator based. So all your arithmetic, add, subtract, logic and or, okay, all these and your load and store instructions are using the accumulator only. However, instructions for transfer between registers, they will use 2 addresses. So if you're moving from one register to another, say from accumulator you're taking it to another register, then you will have a 2 address. Or you are exchanging the contents of 2 registers, you will have 2 addresses. So this is in case of a Intel 8080 microprocessor. And how do you get, from where do you get all these information? You get it in the reference manual. You will get it in the manual of that particular computer. So you can check the manual of any computer and you will find that it will tell you how many processor registers are there, what are the instructions, okay, how many addresses are there in the instructions, which instructions use which, how many addresses, everything is given out there. So that concludes our discussion on the different types of register organization. And why we needed this? We needed this because we need to know how many address fields are there in a instruction.